Hello, my name is Meara Pellar Kosbar. I'm from the Department of Computer Science at Michigan Technological University, and today I'm presenting on simulating the spread of infectious diseases for educational purposes. The drive behind this project was that a number of studies suggested that middle school age students misunderstood the biological mechanisms of disease spread. That is to say, students at this age understood how diseases were contracted, but didn't understand the role that the viral replication that took place inside their bodies played. These simulations were designed to help students understand not only how diseases are contracted, but the biological mechanisms of these diseases and how these mechanisms play into how a disease spreads and grows. The first simulation was a cyber-physical simulation. In this simulation, a number of participants would move freely about a room for 1 hour. At the end of the simulation, each participant would be given a viral count, which was an estimated count of the viral particles on or inside each person's body. For the cyber-physical simulation, what was needed was a classroom, a number of Bluetooth beacons for each participant and for a number of common touch surfaces, an iPod Touch that would collect the distance data that was sent to it every 4 seconds, and this data would be sent to a cloud server which runs the computations for estimating the viral counts for each item and participant. Throughout the simulation, participants will be collecting viral amounts from 3 sources: contact with a contagious participant. Participants can be labeled as contagious before the simulation begins, contact with contaminated items, and collecting viral amounts from the viral concentration assumed in the air. Our other simulation is a fully virtual simulation. This only takes 30 seconds to run and only takes 1 person to set up. The participants in this simulation are represented by small circular icons that move automatically on the grid. For the virtual simulation, there is an adjustable grid which is designed with open floor cells, these are the white cells that the players can move freely on, or item cells, which players can come into contact with but cannot move through. A contagious player can spread viral amounts to other players in item cells through contact. This will leave an item cell contaminated, meaning other players can collect viral amounts from it, and if a player gets a high enough viral count, they will become contagious for a period of time. The settings for the virtual simulation are located right underneath the grid. The student setting up the simulation can choose to adjust the grid size, adjust the time a person is contagious or an item is contaminated, and can choose if their automatically moving players will use masks, social distance, or have the ability to sanitize items. A color gradient will be used for the items and the players to show the level of contagiousness or contamination they have. Moving forward, we hope that simulations such as this will be able to be used in other teaching areas, such as predicting outcomes for climate change based on actions we take now, or doctors could use these simulations to help patients understand the potential outcomes of diagnoses or choices they make with their health now. Thank you all for listening, and special thanks to the Quarren team for doing the front-end design and images for the virtual simulation that were shown in this presentation today.